Polystyrene, the packaging made from beads. Whether it's used to package wine from the Rhine, grapes from Australia, or glass lampshades, whether for packing urgent freight containing machine components or medications, our daily life has long been inconceivable without polystyrene. It protects sensitive, valuable, and delicate goods. It even protects the most valuable thing we have, our head. This is because polystyrene is light and shock-absorbing. It's rugged, but nevertheless yields, and it cushions better than a cushion. And that's why nothing happens if something does happen during goods transportation. Here's a really hard test. It's as easy as child's play to explain why nothing breaks despite this. We'll demonstrate this with a cycle helmet. There's hardly anything more fragile than a normal raw hen's egg. Everyone knows what happens when you drop the egg. It breaks. But there's a way to keep the egg in one piece. And this starts with white or black beads like these. They're sucked into a machine which is filled with very hot water, over 100 degrees, which evaporates to form steam. Let's see what happens technically. Water is heated and steam rises. A sieve above holds the raw material, the black grains. The time-lapse camera shows exactly what's happening. The heat softens the raw material, the vapor pressure of an expanding agent contained in the beads increases and expands them to over 50 times their original size. This is referred to as foaming or expanding. The material is then cooled, dried, aerated, and stored temporarily. This provides the beads with the mechanical stability and additional expansion power required for further processing. The pre-expanded foamed plastic beads, which have been stored temporarily, can be further processed in automatic expanders like this to form a wide variety of packaging and molded articles, like this inner shell of a cycle helmet. Firstly, a separate process is used to produce the hard outer shell of the helmet. After it's set, it's contour milled, provided with breather holes, and then fixed in what's called the casting mold. The cavity between the mold and mating mold is filled with foamed plastic beads, and these are once again expanded with steam. The expansion pressure and the temperature fuse them to form a mechanically high-strength molding. The process is complete a few minutes later. The shell of a cycle helmet made of polystyrene is finished. The other individual parts are fitted on the polystyrene core, gauze breather element, Velcro-type closures, and a head strap. And finally, the safety tested label is attached. And the helmet is now complete. It protects every head and every egg. We've reconstructed a helmet specifically for the size of an egg. So let's take a look and see whether it protects the egg. The egg has to travel 1.5 meters, and of course it has to stay in one piece. And we're in luck, or should we say, we're in a helmet. We're in luck. We're in polystyrene. It protects not only eggs, but if appropriately sized, heads as well, and a great deal more. A good 50 years ago, polystyrene was invented in Germany by BASF. It was produced from styrene, a colorless liquid manufactured from crude oil. During the process of polymerization, many styrene molecules join in a chain pattern to form polystyrene. It's made up only of the elements carbon and hydrogen. Using an expanding agent, it's expanded to form moldings with a wide variety of shapes, not only for packaging. Owing to its insulating properties and its resistance to wet conditions, it's also used widely in the building industry. And because it's as light as a feather and can be shaped easily for model making too. Polystyrene is CFC-free and recyclable. It consists of 98% air. A loading test demonstrates this. The original beads are compressed so much that they contact each other like honeycombs. This structure makes polystyrene extremely resistant and flexible as well. Foamed plastic blocks. If they had handles, even a child could carry them away. It's also possible to make packaging components from blocks like this by form cutting using a hot wire, an economical solution for small lots. The packaging tasks for which polystyrene offers a broad range of solutions are as diverse as polystyrene's own versatility as a material. They differ from product to product and from industry to industry. Packaging engineers develop individually matched solutions, for example for TVs, PCs or refrigerators. Corresponding casting molds are manufactured. The packaging molds are produced in series. Moldings made of polystyrene can also be printed on, for example using the screen printing method, or can be provided with adhesive tapes, like those used for instructions for use or assembly instructions. Foodstuffs can be transported or stored optimally in polystyrene packaging. Because of hygiene-related properties and polystyrene's ability to maintain temperature, it's excellent for packaging sensitive foodstuffs such as fish or deep frozen food. In this case, insulating properties are complemented by mechanical strength. The versatility of polystyrene. It's used for growing and transporting plants which have to be kept moist, for transporting engine valves stored in oil, for medications such as temperature-sensitive vaccines, or for containers for transporting organs. Polystyrene is the preferred type of packaging for a very wide variety of contents. It's no wonder that 200,000 metric tons of polystyrene is used for packaging every year in Europe, and this volume is also recyclable after use. Used polystyrene has no impact on the environment, even on landfill sites or in incinerators, nor does it contain substances which could pollute the air, water or soil. But polystyrene is far too good to throw away. It's 100% recyclable. Domestic quantities are generally disposed of in collection bins. Larger quantities are transported directly to the many recyclable material collection points operated by industry and recycling companies. Large quantities, for instance, from electrical firms or industry, are frequently driven directly to recycling plants, packaged in recycling sacks or unpackaged as complete truckloads. This company in the Black Forest specializes in recycling used packaging and moldings made of polystyrene. The incoming material, which should be as well sorted and clean as possible, is initially separated from extraneous matter such as metal parts and paper. Any stickers and other adhering materials are removed by hand. Every form of polystyrene recycling starts just like this. The spent material is first shredded to the size of a fist, whether simply for subsequent shredding to form flakes, as a soil enhancer for example, or for manufacturing new packaging and moldings. The shredded polystyrene is then reduced mechanically to form single beads. These are used to produce new blocks and packaging moldings. Alternatively, the shredded polystyrene is crushed in a mill to form coarse flakes, the starting material for a new granulation process. Nowadays, much of the polystyrene packaging collected after use is processed like this in a sort of meat grinder. The flakes are heated in what are called extrusion systems, the air trapped in them is released, and the flakes are fused to form compact polystyrene under precise temperature and pressure control. The viscous mass is cast to form billets, which are cooled in cold water and cut to form granulate. The resulting polystyrene granulate is used chiefly to produce injection moulded articles. For example, paper clips, switches, boxes, office requisites, and cassettes of all types. Polystyrene packaging is used for new applications all the time in the various recycling systems. Foamed plastic made of polystyrene protects valuable, delicate and sensitive items. It's rugged and flexible. It's light as a feather. It's thermally insulating and hygienic. It's environment-friendly and recyclable in diverse ways. It can be shaped at will and it's resistant to weathering. That's what it is. Polystyrene.